All right, so I'm assuming that if you're watching this, you're ready for instructions on how to complete this interactive. So first of all, before I get started, what I want to make sure you understand is that these should be treated like notes. So it is more like a digital lab, and you are going to be exploring and learning by doing, but treat this resource, this piece of paper that you printed out, as a piece of paper for notes, something that you'll be referring back to complete practice, something you'll be referring back to study for our unit test. So let's get started. So the purpose of this activity is to explore some relationships between variables for the situation of a block being accelerated across a horizontal surface by an applied force. So you've used this program before. You've pushed this block before, so it should look familiar. But some background. When forces are unbalanced, objects accelerate. So we know this. When there's an unbalanced applied force, objects are going to accelerate. They're going to either speed up or slow down. But what exactly affects acceleration of an object? So we've talked about Newton's second law, how net force is your mass times your acceleration. So if something's mass is increasing, we talked about how its acceleration is going to decrease. Or if we increase the net force applied to something, its acceleration is going to increase. But what effect does the amount of force that is applied, or the mass of an object, or the amount of friction have upon the acceleration an object experiences? So we've talked about mass, but we really haven't talked about friction before. So this whole interactive is focusing on, okay, when we add friction to the scenario, how is acceleration affected by that? And what kinds of things affect friction at all? So in this activity, you will conduct several controlled or simulated studies in order to determine the answers to these questions. So I know it says challenge 1. You are only doing challenge 1 today. You are not moving on to challenge 2. But for challenge 1, we're going to conduct a controlled study. Controlled means that you are keeping certain variables constant. So you may have noticed that I've got some things filled out below already. We're going to talk about that. But controlled means that you're controlling certain variables, because you're not concerned how those variables are going to affect what you're studying, but really maybe something else. So we're going to conduct a controlled study in which we determine the effect of a varying applied force upon the acceleration in the presence of friction. Now we already know how net force affects acceleration, so we're not actually going to be varying applied force. Instead, what we're going to be doing is we're going to see what affects acceleration, or affects friction. So we're going to run several trials in which we collect data to determine the cause and effect relationship. You are not going to plot the data or perform a linear regression to get an acceleration or applied force equation. We're not going to be doing all of that. It's going to be actually much, much simpler. One thing that we do want to know, though, is this note right here. So we need to note that the friction variable that is indicated in the simulation refers to the coefficient of friction. It is represented by this symbol. It looks like a U with a curly tail in the front. This is pronounced mu. It is a unitless number ranging from 0 up to 0.0 or 0.9. Values of mu can exceed 0.9. That just happens to be the upper limit in this interactive. So they're referring to this mu column right here. We call this the coefficient of friction, but for short, we just refer to the variable, which is mu. So what we're going to do is 2 different investigations. We have 8 total trials, but I've color-coded on the left here what we're going to be investigating. So the 2 questions we're going to be investigating is, how does mu affect friction, and how does mass affect friction? So I filled in the table with values that you are going to already put into the interactive, so you don't have to worry about, am I testing the right values, am I controlling the correct variables? We're going to control applied force every single time. Here's how you can tell that it's a controlled variable. It's the same every time. So applied force is not changing. What's changing for my red question is my mu value. It's increasing every single time. So we're really going to see, how does mu affect friction? And then for trials 5 through 8, what's changing is my mass. My applied force and my mu value are staying constant. So just a reminder, over here on the right, velocity time information. Remember, the slope of your velocity time graph is going to be equal to your acceleration. So you're going to be given a velocity time graph and you're going to have to calculate the slope to find the acceleration. That's going to help you in filling this column over here on the right. So your velocity time information is going to look like ordered pairs. What ordered pairs did I pick that I found the slope between to get my acceleration? So I'm going to do trial 1 with you, just so that you can see how you're going to complete the rest of the trials. And then you guys can move on to the form at the end of this. So over here on the left of my screen, I've got the interactive that you guys will have as well. I'm going to just do trial 1. I'm going to make sure all of my settings are just as trial 1 calls for. So I have an applied force of 10, a mass of 1 kilogram, and a mu value of 0.1. So I need to change this to 0.1. So now that everything is set the way I want it, I'm going to push the block, and it gives me a bunch of information. It tells me, first of all, that my net force is 9.02 newtons. So I can already start filling that in. Now I need to figure out what's my velocity time information and what's my acceleration from that. So I'm going to pick a couple of points. So my first point is 1 second and 9.02 meters per second. My second ordered pair is at 2 seconds, and it is 18.04 meters per second. So if I were to find my rise over my run, my rise appears to be 9.02 meters per second, and it changes every second. That's my run. So I can do this in my head because I've been doing this a lot. You might have to work it out on a separate sheet of paper, and that's okay. But once you find the slope between those points, that's going to be your acceleration. Now you may be wondering, what the heck? They didn't tell me what my friction was. Your net force is going to tell you what your friction is. So your friction, I'm going to write up here, my force of friction is the difference between my applied force and my net force. So whatever's left over between applied force and net force, that is my friction. So I can see from trial 1 that my friction is about 1 newton. That's the difference between 10 and 9.02. If I were to go through and do trial 2, I'll do trial 2 really quickly just to show you. The only thing that changes is my mu value. So when I push this block, I get a net force of 8.04 newtons. So now I can already start to see a pattern with what's happening with friction. Why? I can see that in trial 2, my applied force was 10 newtons and my net force was 8 newtons. This means that my friction is about 2 newtons. So it might be wise over here for you to maybe make a 6 column, or I don't know what number column this is, but a far column with friction so you can do the math. There's about 1 newton of friction force in trial 1. There's about 2 newtons of frictional force in trial 2. So it seems like, just looking at trial 1 and trial 2, that mu increasing possibly increases friction. I can't tell with just 2 trials, so that's where I would continue to do trials 3 and trials 4 to see if that pattern holds. But you're going to be doing this for the question in red. You're also going to have to do this for the question in blue, because we're really worried about friction. How is friction affected? And I can't tell how friction is affected unless I'm doing a calculation and figuring out what's the difference between my applied force and my net force. So hopefully this is clear enough instructions, but if it is not, please feel free to message me on Remind, email me, and don't be afraid to ask for help. So I hope you have a great Monday, and I'm looking forward to hearing from you guys if you need some help.